So today we would like to present a project which has been implemented at Qualcomm Technologies, which consists of a massive database of containing nearly all patents of the world. That means so mainly from United States and European Patent Office, and also Asian countries and other countries. Michael Paddon will explain why patents are very important in the world of mobile technologies and for Qualcomm in particular. So as you can guess, all these patent documents are represented in XML. And, but for some reason, the team who has realized the project didn't immediately jump to native XML databases. They made several attempts with other technologies, for example, relational. And it took a kind of long journey before they turned to, they found that actually a native XML database was the best solution. So we try to describe this journey, and also the product that we, native XML database that we have selected, what special characteristics made it successful in this endeavor. So, so first, we'd like to, what is a native XML database? We assume that most of you know, of course, but to avoid any kind of misconception, we'll make a quick reminder. So, a native XML database is any system where you can store XML documents directly without any kind of preprocessing, and no need for a schema. From a native XML database, you can retrieve without loss the totality of what we call the XML data model, which means the data contents, but also the structure and the original order of data. So when is it a good idea to use native XML databases? Is when you have document-centric XML data, which means complex documents with deep structure and mixed with text, which is typically our use case patents. And also it's good for semi-structured data, which means data, XML data with a lot of optional fields and a very variable schema. Sorry. Also, for this reason, native XML databases are good for data integration because the flexibility of this data model can accommodate data from many different sources. Okay, so now we come to the bit controversial part, which you may wonder why we have called this talk native XML databases death or coming of age. We know that there are some good products around which have been here for years, and people among you people have been using it, and I think they are fairly satisfied. So it may sound a bit pessimistic or even a bit shocking for people to hear of this notion of death or decline of native XML databases. The people who have implemented this pattern database actually were not belonging to the XML world, and so they had to answer this question: where are all the XML databases? Do they really exist, or are they good enough? Are they mature enough? So that's probably some kind of prejudices which exist out of the XML world, and that XML databases are something a bit an idea of the past, which has never really gained traction, or really succeeded, or really taken a lot of market. That it is a kind of niche market. So, and it's true that probably 10 years ago there were more products than now, and we have seen a few native XML database products disappear from the market, and also if we look at the research activity, for example, here we have the papers presented in a very large database conference, and here research paper from Google Scholar. We see this very clear pattern of a peak of activity in about 10 years ago, and a sharp decrease since that time. So. Also, there is a clear trend of away from XML. We have seen new ways of representing data. You'll know JSON and how it has, how XML has kind of lost some popularity in favor of JSON, and so now we have also all this NoSQL movement with databases storing JSON directly, like MongoDB, for example. So the question was, are native XML databases really on the decline? And of course, difficult to answer. We don't know the future. But people who have done this project have tried most of the products available native XML databases, and well, the road has been not completely smooth. So probably we can. The best opinion, the most fair opinion about this topic is probably speaking of coming of age. And there is this notion of a Gartner Hype Cycle where you have a trough of disillusionment, which follows a peak of inflated expectations that we have maybe seen in the years 2000 for XML databases, and which is followed by a phase of maturation. And if we compare with the story of relational databases, it took about 20 or 25 years from the first theoretical papers to before the relational databases became mainstream with major products. So in comparison, native XML databases are still young. And also we have to never underestimate the power of conservatism. People move to new technologies only if they get some real advantage, because changing has a cost. And so native XML databases will be used more in the future only if they solve real problems and they are mature enough, and also they have to be easy to use because of the cost of the transition, so they have perhaps to be easier to use than former technologies. So I think it's now time to come back to our use case. Sorry for this kind of digression. And Michael Paddon is going to explain in detail this World Patent Database use case.
Thank you, Xavier. Am I audible? Yep, great. Okay. So we came here today because we want to tell a story. To start, I want to explain that when we started this journey, we knew nothing, right? So we did a whole bunch of stupid things. So as I tell the story, you think, hey, that was stupid. You know why. We were learning. But what we wanted to do was part of our business is dealing with patents, and we wanted to get all the patents that we could get a hold of, all the patents from the US and the EU and WIPO, and put them all in one big database and do all sorts of things with them. And it's a lot of data. There's 19 million XML documents, and some of them are huge. It comes to about 2.5 terabytes of XML. Actually, it's nearly 3 now. It keeps growing. It never shrinks, right? And we get about 850,000 updates a month. But of course, that doesn't come in every day. We get like 100,000 or 200,000 updates dropped on us that we need to process really quickly. So it's a really challenging big data problem. That's what a patent looks like. That's really uninteresting. But more interesting is what the XML representation looks like. So all the patent offices in the world use XML. It's a pretty interesting repository of XML data and a great use case of XML usage. Well, you know, you have organization names, people names, but the most important thing to realize is there's a lot of depth, there's a lot of structure here. Some XML documents you see are just like a flat list of attribute values. These patent documents are not like that. In fact, let me see, I think I've just lost a slide. Here we go. There's a visual representation of the patent database schema, and in fact, we actually didn't show everything. We kind of stopped it at some point because it was getting too large to fit on the slide, but everyone can see that, right? Yeah, there's a lot of structure there. And this meant we needed a real database. If you want to look up someone's last name, there's lots and lots of last name fields. It might be the last name of an attorney, it might be the last name of an inventor, it might be the last name of an assignee. And depending on what you're looking for, you need to take account of the structure. So you really can't just flatten this out and stick it in a flat database. So that's the sort of thing we're talking about. You need to write, if you're thinking index query, you need to write fairly complicated X queries to get to what you want to get to. Okay. So our requirements were, what we wanted to do with this database was, well, just about everything. People often say to me, what do you do with this database? And the answer is lots and lots of different things. Sometimes we have programs go through the database and extract huge amounts of data and do machine learning. Sometimes we have individuals, sitting there typing queries, looking for something very specific. Sometimes we have people running statistical analyses. We couldn't tell ahead of time exactly how people would use the database. And this turned out to be really, really important when we actually went and tried to find out how to manage this sort of data. So we started our quest. And there were two basic approaches that we could take. One was to take all this XML data and turn it into something else and put it into a traditional type of data management system. And the other approach was to use a native XML database. So of course, being stupid, we did try the first one first, right? We ran into all sorts of really interesting problems. So I guess just to run over them quickly, you can try and write a schema in a relational database like Oracle or Postgres and try and map this XML into the schema. And then when you're finished, what you find is that you want to run a query on something you decided wasn't important, so you hadn't bothered to bring across. Or you try and bring everything across and then you discover that the schema's changed. Or you try and bring everything across, and then you discover that I can't write queries for this database anymore because I've got like 400 joins. And I'm trying to write SQL queries with like all these joins. So it's a Sisyphean task. We spent a long time trying to map all this XML data into a relational database system, and it was a stupid thing to do. You don't do that, you know, we learned. And so, yeah, the schema maintenance killed us. We tried, as I said, we tried automatic shredding, but, you know, the writing the queries killed us. So we tried key value stores, right? You know, classic NoSQL. And what we discovered there was the joins killed us. So, of course, we could turn every XML element into just a key value store and then pull these things in quickly from the key value store. But then we had to do all of the logic. You know, is this last name actually the last name of an inventor or an attorney? We had to do all that in the business logic, and it meant huge joins in our code. And that really sucked, and that didn't work. So we started to get pretty depressed at that point. We did try also, you know, mapping into full text search engines, but again, we were losing all that structure that was so important. You know, it was just the wrong solution for us. And of course, you know, we had to look at other systems like JSON, and I guess the best thing I can say about JSON is it's fantastic for making websites. It's like XML without all the good bits. So that really wasn't what we were looking for. We wanted to do queries. There's no standardized JSON query language like XQuery. It's not really a database in the sense that we needed a database. Okay, which, you know, finally, you know, the horse got led to water, and we decided, okay, we'll try these native XML databases. So we actually used a whole bunch of them, and there's some really good products out there. And you know, nothing I say it should be regarded as negative against any of those products. But what we found is all the products have different strengths and weaknesses. So some products are really good at importing, but are slower at querying. Some products have size limitations. You know, when you start to put terabytes of data in, issues arise. So we experimented with a whole bunch of different native XML databases, and eventually we found a little product called Quizzix, which I'll explain why we own it now, but back then it was just a third-party product. And it was really cool. It had all the features that we wanted, and the important ones for us were, you know, it was native XML, so we didn't change the data. This is like the golden rule of big data, right? You never ever change the original data. You just stick it in the database and then pull it out when you need it. It had full XQuery support, which is super important to us because we wanted to use a standard query language. You know, it has REST servers, all the standard things you expect of a database, and it runs on Java, which is great, so it'll run anywhere. And the other really cool thing it did for us was it does automatic indexing, which was great because remember I said we didn't know how people would use our database. And in fact, every time people use our database, they think of new ways, new sorts of queries I want to write. And so that automatic indexing was super important to us as it turned out. But we didn't realize that until we put it into practice. And there's a bunch of other really cool technologies in there like metadata support, which again allows us not to change the original data when we're doing analysis. So anyway, we liked the product so much, it solved our problem. That native XML database solved our problem so well. It's like that electric razor commercial from the 1970s where the guy liked the razor so much he bought the company. So we liked the Quizzix technology so much that Qualcomm eventually decided we'd buy it. So it's now Qualcomm Quizzix, and it works even better than it did when we chose it. So if you've got a problem like this, you know, please come and talk to us. Which I guess brings us on to the lessons we learned. So this really wasn't supposed to be a marketing talk. It's a technical talk, so we learned a bunch of lessons. And I think Xavier was going to tell us a little bit. Okay, well, the native XML database was the only solution that worked for us. This was the really most important message, the only solution. We couldn't have solved our problem any other way as it turned out. And so if you are looking at big data problems like this is the path to go, regardless of which technology you choose. And as I said, you know, the automatic indexing was really, really important as it turned out. because you don't know when you're in the big data world, you just don't know what the next query is going to be about, so you can't know which indexes to create. That's a really key thing we learned.
And also because when you have a database which is a few gigabytes big, automatic indexing is a convenient feature, but when here you have a database which is several terabytes big, reindexing is really a serious task. It can take several days, so it's really important to avoid to define new indexes, and it really saves a lot of time. As a conclusion, I wanted to give some thoughts. So I wanted to insist on this notion. We call it just store and query, which is a general principle that we want XML database where all you have to do is just import documents, and then you can run queries at the best speed. That means using indexes without any need to define and tweak your own custom indexes. So that's why you need automatic indexing. Of course, it's not always possible because XQuery is a complex language and you can write very complex queries. But we think this is a kind of effort. We have to strive to design intelligent compilers to try to reach this goal. And also I wanted to point out that when you have automatic indexing, that means you index the structure and also the values. You have range indexes which are built automatically. Then it's a very good basis also for further intelligent optimizations. Because you can build also secondary indexes or derived indexes from the automatic indexes, and it costs a lot less than scanning again all the data in the database. And also we found that standard and complete full text report is something very important because of the textual nature of document-centric XML. And here there is, just wanted to mention that as far as I know, the full text XQuery full text standard is not completely finished. So we are lacking a few features, which is mainly the quick retrieval of the most relevant results. You can write that in XQuery, but that's the blue snippet. But as you can see, it's a bit cumbersome, and it's difficult also to optimize for a compiler. So we think we would need a standard function to express that simply. And also we need highlighting and snippet extraction. And also we think that a call feature is something which doesn't exist yet in QuizX, but that we want to develop and provide is a faceted search. I think maybe I'm going to lack time to explain this. Faceted search is a way of, can be seen as a way of abstracting properties of application level objects. And I just wanted to mention that it could be a great way of also coping with this variability of data schema in real big data XML data application. But this should be a topic of another, I think, a future talk. So that's pretty much what we wanted to say. And so now we can take questions if you have.
Right, we have time for a few questions. Any questions? Oh, we got one here. Hans? Whilst he's going there, do you guys use REST-XQ at all in BaseX for defining your RESTful interfaces?
REST-XQ.
No, sorry. We have QuizX has its own REST interface, and we don't yet support this. Actually, I don't really know it, and but we have quite a comprehensive REST interface.
Thank you.
Okay, so I just looked at the schemas of the US Patent Office and the European Patent Offices, and they look quite similar in terms of structure. But my question is there an effort going on making a global standard of describing patent documents?
Yes, there is. Well, global's maybe a bit stretching it, right, because there's a lot of countries involved. But the European Patent Office and the US Patent Office in particular are trying to unify, their data. It's a many-year process. And then, of course, there's patent offices in China and India and everywhere else in the world, and they're all working together, but it's a very slow thing. Yeah.
One question: are those patent documents completely self-contained, or do they reference each other?
They reference each other. They don't do so using things like formal links, but there's citations. So what you want to do when you're processing this data is to go forward and back and process the citations, and then perhaps create metadata which you can follow more easily later on.
Any other questions? Right, thank you very much. Thank you.
Thank you, everyone.